Today we'll be looking at lesson 3.4, which is dealing with number lines and fractional number lines and how we can use those number lines to answer different types of questions. So our first situation here says divide the number line to show sixth. So that means from 0 to 1, I need to split it into 6 equal pieces. So what I like to do is I like to start here in the middle. I know that's going to be half, so I'm going to need 1, 2, the middle one there is 3, 4, 5, and then the 1 is my 6, 1, so this would be 1, 6, 2, 6. Kind of fast forward ahead, 5, 6, and then 1 could also be rewritten as 6, 6. Then I need to split up from 1 to 2 the same way. Start in half. There's 2 there on that side. There's another 2, and then we go 7, 6, 8, 6. And again, I fast forward ahead a little bit, 9, 6, 10, 6, 11, 6, and 12, 6. 12, 6, if you do 12 divided by 6 is 2, and everything checks out. So I was able to split that into 6. Now let's come down to divide the number into fourths. Fourths is one we're a little more used to here. So there's my first one here. So there's going to be halfway. So I go half and half. So there's 1/4. The middle one is 2/4, 3/4. 1 could also be looked at as 4/4. Then I need to split from 1 to 2 into quarters or fourths again, and then can continue. Is 5/4, 6/4, 7/4, and then 2 could also be written as 8/4. And I'll come in and write 1. We could also call that 4/4. All right, now we're going to use some of this information to come down below and help us determine which number is larger. So we have 5, 6, and 3/4. So we could actually use, you used your finger, I'll use this pointer. 5, 6 is here, 3/4 is back here. It's very close, but this shows that 5, 6 is indeed a little bit bigger than 3/4. Now we have 7, 7/4 or 7, 6. Some may think just because the top number is the same, they might be equal. But when we look at the number line, 7, 6 is back here, 7/4 is way up here. So if we drew a line up, actually 7/4 is much larger, and that's because the 6th is a smaller piece, a smaller space, so when compared to a 4th. So this time, 7/4 is going to be the biggest. And then just to go over that same idea again, we have 2, 6, and 2/4. 2, 6 is back here. 2/4 is up a little bit, which would line right up with 3, 6. So this one was a little closer than the last, but 2/4 is indeed larger. Now we could also use this to rename fractions. So another name for a fraction on 11/6. So 11/6 is right here. Okay, and what we can do is one thing, the way I labeled them, I just counted right up through 6, 1, 2, 3, the whole way up to 12, 6. If I start though at the 1, I could also start to call 7, 6 would be 1 and 1/6, 1 and 2/6, 1 and 3/6, 1 and 4/6, and where I'm at now, the 11/6 would be 1 and 5/6. Could do the same with my other number line in the fourths. 1, 5/4, I could also call this, let's see if this shows up. I'll just talk through it. It would be 1 and 1/4, 1 and 2/4, 1 and 3/4, which 1 and 3/4 could also be called 7/4. Now we just have some other practice that we've been doing with standard notation and exponential notation. So the left box and the right box are opposites. So what we're trying to do now is the left box, we're renaming each number using standard notation. We're trying to make it look, I always tell my students, standard means just the normal way we would write a number. And the way we do this is, remember, 4 times 10 to the third is really 4 times 1,000, which is 4,000. Another way to think your way through it, it would be a 4, and since it's times the 1, we could just add on 3 zeros. So 7 times 10 to the second. 10 to the second is a 1 with 2 zeros, so it's really 7 times 100, which is 700, or again, it would be the 7 with 2 zeros. And our final problem, 9 times 10 to the 6th. 9 times 10 to the 6th, that would be a 1 with 6 zeros, which is going to be a million. So 9 times a million is going to be 9 million. All right, so now we need to rewrite each number as a product using exponential notation, which is the opposite of what we just did. So we're looking at 800. So if I break that down, that really means 8 times 100. Okay, so I'm going to do 8 times, I'm going to change my 100 to a power of 10. So it's going to be 10, and how many zeros are in 100? There are 2 zeros, so my exponent should be a 2. So my answer for that one, 8 times 10 to the second. My next problem, I have 50,000, which is really 5 times 10,000. So I can do the 5 times 10 to the what power? So again, I need to come back. I need to look at my zeros. I need to count 1, 2, 3, 4. So that's going to be 10 to the 4th. So 50,000 is 5 times 10 to the 4th power. And I threw this last one in here, not to mess with you, but just to keep you on your toes. 1. So 1 could be rewritten as 1 times 1. All right, so that would be 1 times, how do I do a power of 10 that equals 1? And that is, you don't typically write this one, but that would be 10 to the 0 power. And the way I remember that is 10 to the 0 power is a 1 with 0 zeros. So 1 times 1 is 1. I hope that helped.